Yes students, welcome to our video lecture. Now in exercise 7.8 we have studied the value of definite integral as a limit of sum. We were finding limit of sum. Now in that part students, I taught you that actually the value of definite integral is nothing but area under the curve. So this is a continuous function y is equal to fx. Say this value is x is equal to a, and say this value is x is equal to b. So if I want to find the value of integral a to b fx dx, if I want to find this value, it is nothing but area bounded between the vertical lines x is equal to a, x is equal to b, and x-axis, and the continuous curve y is equal to fx. This I have already taught. Once again, students, if I want to operate integral a to b fx dx, then that value is nothing but area bounded by this continuous curve x-axis and the vertical lines x is equal to a and x is equal to b. So suppose x is any value belonging to closed interval a somewhere here. Then students, the area bounded between x is equal to a and this x will be area function ax is equal to integral a to x fx dx. This part. So if your x is a value belonging to closed interval ab, and if I want to find area bounded by this curve x-axis and between these two lines, then it is dependent on x. So this area is obtained as integral a to x fx dx, and this function ax is defined as students area function. Provided x belongs to closed interval ab, x has to be any value within the frame of closed interval ab. So that area is dependent on x, and that is why we return the function as ax. So this function ax is called area function. Based on this students, we have first fundamental theorem of integral calculus. If I am going to differentiate this, then definitely a dash x is equal to fx. So what is our first fundamental theorem of integral calculus students in textbook? It is given on page number 335. Let fx be a continuous function of closed interval ab, and x be any value within the frame of closed interval ab. And if ax is the area function, then definitely a dash x will be equal to fx. Then the second fundamental theorem of integral calculus. If the integral of small fx dx is capital Fx, then integral a to b small fx dx is capital Fx limit from a to b. It is nothing but functional value at upper limit minus functional value at lower limit. This is taught to you by kids in physics also. And proof of this theorems are above the scope of textbook. In textbook also you check, students, they have notified the theorem, they have given the statement of theorems. So as such students, we have two fundamental theorems of integral calculus. One is based on area function and other is based on the value of integral, where the answer of integration is obtained integral at upper limit minus obtained integral at lower limit. The value of definite integral is always a real constant, because as such it is studied as area under the curve. So today we studied area function, Based on area function, students, we have first fundamental theorem of integral calculus and second fundamental theorem of integral calculus is also generally based on this area function only. But mind you, the function which we are integrating must be a constant continuous curve within the frame of domain. Otherwise, students, we cannot find this area. The function which we are integrating must be a constant continuous curve within the domain A to B. Now, students, let us apply especially the second fundamental theorem of integral calculus to sums. So we are starting exercise 7.9 and noting down the first 5 sums. Exercise 7.9. These are easy but important sums demonstrating the second fundamental theorem of integral calculus. So students, all of you please try to understand this basics very perfectly. Now students, say the first question is exercise 7.9, question 1. It is integral -1 to 1 x plus 1 dx. Second question is integral 2 to 3 1 upon x square dx. Okay. And third, it is integral 1 to 2 4 x cube minus 5x squared plus 6x plus 9 dx. Okay, students, let us do 3 questions at a stretch. Okay, first step we will operate, we will call this as I. In the first step, we will only operate indefinite integration. Now, what is integration of x plus 1? At this level, I did not teach. Integration of x is x squared by 2. Integration of 1 is x plus c. And let us call this as capital Fx. So, according to second fundamental theorem of integral calculus, the value of I will be f of b minus f of a. So it is f of 1 minus f of minus 1. So first I take the value at 1, which is half plus 1 plus c. I take value at minus 1, which is half minus 1 plus c. C and minus c gets cancelled. Half and minus half gets cancelled. So the answer is 2. This is how, students, we have to apply the second fundamental theorem of integral calculus, students. I hope all of you have understood. Now, I am doing the second sum, students. All of you pay attention. I call this as I. First, I operate indefinite integration. What is integration of x raised to minus 2? It is x raised to minus 1 upon minus 1 plus c. And this is nothing but capital Fx. So, according to second, I am writing in short, fundamental theorem of integral calculus, the value of I will be f of b minus f of a, f of 3 minus f of 2. F of 3 will be minus 1 by 3 plus c, and f of 2 will be minus 1 by 2 plus c. So the answer will be half minus 1/3, so 1 by 6. This is how, students, we have applied the fundamental theorem of integral calculus. Again, I call this as I. First of all, I operate indefinite integral. Integration of 4x cubed is nothing but x raised to 4. This is 5 by 3x cubed. This is 3x squared plus 9x plus c. The value of integral according to fundamental theorem, second fundamental theorem of integral calculus, f of 2 minus f of 1. I hope you can easily simplify so get the answer. So this is how, students, we have to apply. Now this much I am leaving as homework. All of you can easily do this. Okay, students. Now we are doing questions 4, 5 and 6. Okay, students. Our next 3 sums I am writing on the board. These are very easy sums, students. I hope you can easily simplify and complete the answer of sum number 3. Now, students, the question 4, 5 and 6. At a time I am writing only 3 questions, students. Question number 4. Integration 0 to pi by 4 sine of twice x dx. Then fifth, integration from 0 to pi by 2 cos of twice x dx. And sixth, integration 4 to 5 e raised to x dx. Okay, students, let us do the sums. First of all, I operate indefinite integration of sine 2x dx. All of you know integration of sine of ax plus b is minus 1 by a cos of ax plus b. So this will be minus 1 by 2 cos twice x plus c, and this is our capital F of x. So according to fundamental theorem, second fundamental theorem of integral calculus, according to second fundamental theorem of integral calculus, this will be f of b minus f of a. So f of pi by 4 minus f of 0, so minus 1 by 2, and it will be 2 into pi by 4, so pi by 2 cos pi by 2 is 0, minus f of 0, cos 0 is 1, so minus half plus c, so the answer is 0. C and c gets cancelled, this is half minus half. So this answer is, students, 0. Now, the next question, students, sum number 5. I hope all of you have understood this. This is 2 into pi by 4, so this will be pi by 2 cos pi by 2. So, students, the answer is half. Sorry, students, here this is already 0. Sorry, students, the answer is half. Okay. Now, students, the fifth sum, integral 0 to pi by 2. So first of all, I am operating the indefinite integration cos of twice x dx is equal to 1 by 2 sine of 2x plus this one of you know. So, according to second fundamental theorem of integral calculus, I becomes f of b minus f of a. So f of pi by 2 minus f of 0. So half sine pi will be 0 minus f of 0. Sin 0 is also 0. So the final answer is, students, 0. So now question number 6, students. First of all, I operate indefinite integration of e raised to x is e raised to x plus c, and this is nothing but capital f of x. Now these are very elementary sums. According to second fundamental theorem of integral calculus, this will be f of 5 minus f of 4. So e raised to 5 plus c minus e raised to 4 plus c. So the answer is e raised to 5 minus e raised to 4, or e raised to 4 into e minus 1. Okay, students. Now we are doing questions 7, 8, 9. Now, students, we are doing the next. These are all very elementary sums, students, with limit. So one has to be very careful, and one has to be a little bit faster in simplifying, students, the answer. Okay, question 7. I is equal to integration 0 to pi by 4 tan x dx. Question 8. I is equal to integration pi by 6 to pi by 4 cosec x dx. Okay. And question 9. I is equal to integration 0 to 1 upon under 1 minus x square dx. Okay, students, let us do these three sums. Now when I operate indefinite integration tan x, isn't it? Tan x is, you can say, what is integration of tan x? Log mod sec x plus c. And this is equal to fx. All of you know this. Now, the value of integral according to second fundamental theorem of integral calculus is f of b minus f of a. So f of pi by 4 minus f of 0 log mod sec pi by 4. Now cos pi by 4 is 1 by root 2, so sec pi by 4 is root 2 plus c minus f of 0, sec 0 is 1, so log 1 plus c, so the answer is half log 2. You are writing at log of root 2, it is correct. Now, students, here first of all I will operate indefinite integration. Integration cosec x dx is log mod cosec x minus cot x plus c, which is equal to capital F of x according to second fundamental theorem of integral calculus. This is f of pi by 4 minus f of pi by 6. Now I can leave these calculations for you to complete, students, and find out the answer. Cosec pi by 4, so here I should write root 2, and cot pi by 4 is 1. So if you want, I can add one more step. Log of root 2 minus 1 plus c minus cosec pi by 6 is 2, and cot pi by 6 is root 3 plus c, and simplify, students. Cot pi by 6 is, you can say, root 3. A minus log B, you can take it as log of A by B and simplify and get the answer, students. Okay. Now, what is the integration of 1 upon under root 1 minus x squared dx? All of you know this. Indefinite integration dx upon under root 1 square minus x square is nothing but sine inverse of x plus c, and that is fx. So according to second fundamental theorem of integral calculus, this is f of 1 minus f of 0. Sine inverse 1 is pi by 2 plus c. Sine inverse 0 is 0. So the answer is pi by 2. So students, these concepts are fundamental based on the two most important fundamental theorem of integral calculus, students. Let us do one more sum and then, students, we will start. Remaining questions, students, we will do in the next lecture. Let us do sum number 10. It is integration 0 to 1. Sum number 10. Integration 0 to 1. 1 upon 1 plus x squared dx. Now integration 1 upon 1 plus x squared dx is nothing but tan inverse x plus c. This is capital F of x. According to second fundamental theorem of integral calculus, this is f of 1 minus f of 0. Tan inverse 1 is pi by 4. Tan inverse 0 is 0. So the answer is pi by 4. So these are all elementary sums. But students, based on the most important fundamental theorems of integral calculus, remaining questions from 11 to students 22 will complete in the next lecture. So here we conclude the lecture, students. Understand and write the statement of theorems twice. That area function, then you can say the first fundamental theorem of integral calculus, which is a dash x is equal to fx, and the second fundamental theorem of integral calculus, which is integral a to b fx dx, is capital Fx limit from a to b. So it is integral value at upper limit minus integral value at lower limit. Okay, students, we conclude here. Thank you.